conditional probability. Let me explain the notation first. This is a short vertical bar. The event behind the bar, to the right of the bar, that's the condition. So the probability means the probability of A occurring under the condition that B has already occurred. This is a conditional probability. Simply put, a conditional probability is a probability with a condition. The condition is whatever the event behind the bar, to the right of the bar, that event has already occurred. Let me give you an example, and we look at the difference between a conditional probability and a regular probability. Okay? Let's consider rolling a die. You should know the sample space contains 6 outcomes. You either get a number 1 or 2, 3, 4, 5, 6. Okay? So if you let A be the event with the result, you get a number 6. And B would be the result that you get an even number. Let's see the probability of A and the probability of A given B. This is called a given. This is called a given. So how do we read the notation? P of A given B. P of A given B. Given the condition, given that B has already occurred, what's the probability of A? Let's see. P of A, what's the probability of getting a number 6 if you roll a die? We know that is 1 over 6, right? And let's consider P of A given B, the conditional probability. We know that B has already occurred. We know that B has already occurred. Means you already know the number from the die is an even number. Then would you consider 1, 3, and 5? Of course you wouldn't, right? Because even number 1, 3, 5 are not even numbers. So given the condition that B has already occurred, then we would shrink the sample space to 2, 4, 6. So all the possible outcomes that you are considering right now, not 1, 2, 3, 4, 5, 6 anymore, only 2, 4, 6. So you're kind of considering 3 possible options, 2 or 4 or 6. And under that condition, you get A. The probability is 1 over 3. Do you see what I'm saying here? That's the difference between a regular probability P of A and the conditional probability of P of A given B. Do you see what happened here? And if I make it even harder for you, so how do you find the probability of A given B bar? The condition is different right now. Condition is B bar occurs. What is B bar? If B is getting an even number, then B bar, the complement of that event, would be odd number, right? So you know you have an odd number already. You know that you got an odd number. You know you got an odd number. Then of course you wouldn't consider 2, 4, 6, right? Under the condition that you got an odd number, what's the probability of you get a number 6? Is that even possible? So among the 3 odd numbers, 1, 3, 5, none of them favor you getting a number 6, right? So that is 0. Maybe this would help you understand better about what is conditional probability. Alright, let's see the formal definition here. The conditional probability of an event B is the probability that the event will occur given the knowledge that an event A has already occurred. This probability is written as P of B given A. Yeah, when we talk about the example, we use the example of P of A given B. Here is a P B given A. It's the same, it's just different order, different letters. A is the condition in this case. Notation for the probability of B given A. I think we are going to talk about two examples, and you would have a better understanding about the conditional probability here. Example 1. Consider a procedure that randomly selects 2 marbles without replacement. Here the keywords without replacement from a bag containing 10 marbles consisting of 3 red marbles and 7 green marbles. Let A be the event that the first time a green marble is selected. Let B be the event that the second time a red marble is selected. Determine P of B given A and P of B given A bar. Okay, here, that's the bag. It has 10 marbles, 3 red, 7 green. Okay, so remember, A is the first time you get a green. B is the second time you get a red marble. We are looking for, I would have to erase that and have enough space to write something, write a solution. We need, for example 1, we need to find firstly P of B given A. P of B given A. Okay. How do we find the P of B given A? Let's consider, what does the notation mean? It means the first time. We know the first time we got a green marble already. Under that condition, the probability that the second time I get a red marble. Because the experiment is without replacement, very important, without replacement. So the first time I got a green marble. The first time I got a green marble, so means it's already occurred the first time I got a green marble, right? So before I go ahead to take the second marble, because without replacement, how many marbles in the bag right now? Without replacement, the first time I got a green marble, and I do not put it back, I threw it away. So before I go ahead to take the second marble, I only have 9 marbles in the bag. Do you agree? Among the 9 marbles, I don't have 1 green marble anymore. I have 6 green marbles, 3 red marbles. And among the 9 marbles, how many of them favor I get a red marble? 3, right? Do you see what happened here? So when we consider conditional probability, we have to include the condition. We have to change the original sample space. Like example 1, we are doing without replacement. So when we consider event B, we don't have 10 marbles anymore in the bag. We only have 9. Among the 9 marbles, we have 3 red. So 3 goes on the top, 9 goes on the bottom. That is 1 over 3. Is that understandable? We also need to find the probability of B given A bar. This time the condition is different. We know that the first time we are not getting a green marble. A bar has occurred. A bar has occurred. That's the condition. What does that mean? Means the first time I get a red marble. A represents the first time get a green marble. Then A bar would be the first time I get a green, A represents the first time you get a green marble, right? Then A bar would be the first time you get a red marble. And without replacement. So you are missing 1 red marble here. So when you take the second marble, you have 9 marbles in a bag. And how many of them favor the result, getting a red marble? Only 2. Because you got a red marble the first time. So the 9 marbles right now only has 2 red marbles. So that is 2/9. So you see the difference here without the replacement. Without the replacement. A occur or not does affect the probability of B. A and B are dependent. You see what I'm saying here? A occur or not does affect the probability of B. You can see the difference, right? They are different. When that happens, we say A and B are dependent. Of course, A affects B, right? Example 2. Considering a procedure, you randomly select 2 marbles with replacement. The key word here is with replacement. From a bag containing 10 marbles, consisting of 3 red marbles and 7 green marbles. Let A be the event that the first time you get a green, B as the event the second time you get a red marble. Determine the 2 probability, the 2 conditional probability. The first one is P of B given A. Let's see what's the probability. A is given. A has already occurred. The first time you already got a green marble. Okay, but you put it back with replacement. So before you take the second marble, you still have 10 marbles. Among the 10 marbles, you still have 3 of them favor you getting a red marble. So the probability is 3/10. Do you see what happened here? And the second conditional probability is B given A bar. Condition is different. Now we know A bar has occurred. A bar has occurred means the first time you got a red marble. The first time you get a red marble, because A represents the first time you get a green, so A bar would be the first time you get a red marble. It doesn't matter because first time you get a red marble and you put it back with replacement. So when you take the second marble, you still have 10 in the bag. You still have 3 favor the red marbles result. So the probability, the conditional probability is still 3/10. Am I clear about that? You see, they are the same. A occur or not doesn't matter, does not affect the probability of B occurring because we are doing with replacement experiment. In this case, A and B are independent. A occur or not does not affect the probability of B occurring at all. You can see that clearly, right? This case is independent. So again, without replacement, dependent. With replacement, independent. Okay, so another 2 examples. We are going to talk about the multiplication rule. This is still multiplication rule. Remember, guys, when you need to find the probability of A and B, you know you're going to apply multiplication rule. But before you go ahead to find the correct formulas, you need to determine are A and B dependent or independent. So let's look at example 1. Consider a procedure that randomly select 2 marbles without replacement. Without replacement. What is that case? That case is dependent, right? Without the replacement. From a bag containing 10 marbles with 3 red, 7 green. Let A be the event the first time you get a green marble, B be the event the second time you get a red marble. Determine P of the first time a green marble is selected and the second time a red marble is selected. Means we are looking for P of A and B. We are looking for the chance, the probability that the first time you get a green marble and the second time you get a red marble. So we are looking for probability of A and B. Remember, in this case, without replacement, A and B are dependent. So what formula? Which event occurs first? A occurs first, right? So we would use this formula. P of A multiplied by P of B given A. Because when you consider the chance for B occurring, A has already occurred. Does that make sense? Okay, so what's the probability of A? Probability of A is you have 10 marbles. The first time you get a green marble. 10 marbles. How many green in it? 7. That's the probability of A, right? How do we find the conditional probability? Now we know the first time you get a green without the replacement. So you have 9 marbles only when you take the second marble. Among the 9 marbles, how many of them are red? 3. Because you took away a green marble. You still have 3 red marbles, right? So you multiply them together, you have 7 over 30. That's the application of the multiplication rule for finding the value for P of A and B. And in the case that A and B are dependent. Okay, so you would have to start from the event which occurs first. You would have to start from the event that occurs first, and then multiply by a conditional probability. In a conditional probability, the condition is A has already occurred. Example 2, with the replacement. Remember, with the replacement is the case that the two events independent, right? Independent. Okay. A procedure, randomly select 2 marbles with the replacement from a bag with 3 red, 7 green. A is the event the first time you get a green. B is the event the second time you get a red. You need to find the probability of A and B. P of A and B. Well, you know, I'm going to apply the multiplication rule, but I need to determine are A and B dependent or independent? Independent, so the formula would be different. Remember the chart, the flow chart that I showed you in previous video. In the case that A and B are independent, P of A and B equals P of A times P of B. Okay, what is P of A? We know that 7 over 10, right? 10 marbles, 7 of them are green. P of B, second time, you got a red marble. Remember, you put the first marble back with the replacement. So when you take the second marble, you still have 10 marbles. 3 of them are red. So that gives you 21 over 100. All right? Because in the case that A and B are independent, A occurs or not doesn't affect the probability of B. The first step, what kind of marble you get, doesn't matter because you put it back after, right? So the probability of B would be 3 over 10. Like here. A occurs or not, the probability of B occurring always 3 over 10. So from these 2 examples, we understand how do we apply multiplication rule to compute the probability for A and B. We need to determine are A and B dependent or independent because we have different formulas in the 2 different cases. Next topic, treating dependent events as independent. So when you apply multiplication rule, do you like the case that A and B dependent or do you like the case in which A and B independent? Of course you like independent, right? You don't really like, I believe you don't really like to compute the conditional probability because it's more complicated. So here we have a 5% guideline for cumbersome calculations. When calculations with the sampling are very cumbersome and the sample size is no more than 5% of the population size, treat the selections as being independent, even if they are actually dependent. So let me explain what does that mean. Maybe we can just explain that from through example 3. A company has 10,000 employees consisting of 9,950 non-smokers and 50 smokers. If 20 employees are randomly selected without replacement, when you see the word, what does that mean? Without replacement. That means that is dependent, right? Of course, every time you interview one employee and you are done with him, you are not going to put him back, right? So 20 here is the sample size. And the 10,000 here is the population size. Find the probability that they are all non-smokers. So let's see how do we do that. First, we need to check, is the 5% guideline applied? We need to find the ratio of the sample size and the population size. 20 divided by 10,000, 1, 2, 3. So that gives us 0.2%. Here, since the sample size is 0.2% of the population size, the 5% guideline applies here. So even is an experiment in which those events are dependent, so we can see them as independent. Then the probability that all of them are non-smokers. If we let AI be the ith person is a non-smoker. A sub 1 is the first person non-smoker. A sub 2, the second person non-smoker. A sub 3, the third person non-smoker. A sub 20, the 20th person non-smoker. You understand the notations here, right? Then we are looking for the probability of A1 and A2 and so on and A20. That is a multiplication. So we are applying multiplication rule. If we are using dependent formula for the multiplication rule, this is how complicated it is, okay? I don't mind to spend time. Oh, we over 20 minutes. I hope we are still okay. The formula is going to be P of A1 times P of A2 given A1. Because when you take the second person, the first person is gone, right? And the P of A3 given A1 and A2. When you interview the third person, the first and the second person have already taken away, right? And so on and so on. P of A sub n over A1, A2, and AN sub 1. You see how complicated that is. What's the probability of the first time you got a non-smoker? So the population size is 10,000. 1, 2, 3, 4. The first person is a non-smoker. That would be 9950. Here we are talking about empirical probability. So 9950 non-smoker. So the randomly selected person is a non-smoker is this number, okay? And the conditional probability here, you are interviewing the second person, but the first person is already gone. So you don't have 10,000 anymore, you have 9999. Among the 9999, how many non-smoker there? The first person is a non-smoker, right? We already know the first person is non-smoker, so here you have 9949. And so on and so on. You would see it's so, what's the word? Cumbersome. troublesome, very complicated. You don't want to do that. You don't want to do that. So under the condition, under the requirement is satisfied. If the requirement is satisfied, the sample size is 5% less than the population size, then we can pretend that is they are independent. Okay? Turns out when we pretend that they are independent, the result is very similar with where we get the result that we use this formula, very complicated formula. So now we assume they are all independent. Then the multiplication formula would be P of A1 and A2 and A20 equals P of A1 times P of A2 times and so on times P of A20, right? And each single of them equal to 9950 over 10,000. So that gives us the 20th power of 9950 over 10,000. That is about equal to 0.90461. That is a 5% guideline. Very important in reality, in the application.